This is second part of our video in which we are exploring classes, constructors, and assignment operators. We have created a class credit card account that has two attributes. The first attribute is name of the customer, that was called CNAME, and the second attribute is the balance. So we created one object that was called cat. So cat was of type credit card account. The name was Mr. Watson. Then we now want to improve the method that modifies the balance. We have created balance is private attribute, and we have created a function that allows us to change the balance. Now we want to improve this experience of changing the balance. We actually do not want the programmer in the main function to simply state, I want the balance to be changed to the number 29.95. Instead, we want the programmer to put the number that is equal to the charge that the customer made. So what is the charge? Customer goes to a store, customer buys an item, the price of the item is $15.10. That is the charge. So we want the balance to be updated by $15.10. If customer goes to a store again and purchases something that costs $15.20, now the balance should be bigger, so should increase by those additional $15.20. And on top of all of this, we want to keep track of all purchases that a customer has made. So it seems that stack is an ideal data structure that can be used to keep track of all purchases, and as a special case, it's going to be easy to calculate the final balance. Since we will now add more attributes to our class, I will have to make this customer name and balance a little bit smaller and to make room for a stack. So we will now use stack that we already created, and that is in imomath.com bmath. So our lecture notes for the class are located at this address. So please go to your lecture notes, find the implementation of the stack, and put it here in the beginning of the code. So that is what I'm going to do now. I will copy paste from the website, from the lecture notes, the implementation of the stack. Now, once implementation of the stack is created, we have another class, SN, stands for stack node. Now I will add another private attribute, pointer to the head of the stack, and we will call that pointer AHT. AHT stands for address of the head of the transactions. Now let's see how would that look in the picture. So our class will have additional field, address of the head of the transactions, and now we want to, instead of the method change balance that we will now erase, we will create the method add charge. Again, the argument will be real number x, and if the method will be called in the following way: cat add charge 15.1, and if charge of $15.10 is added to the credit card, we want the memory diagram to be updated by 15.1 appearing in the stack, and address of the head of the transactions is going to point to that number 15.1. We want the method add charge to achieve two outcomes. The first outcome is increasing the stack of all the transactions. The second outcome is updating the balance. So balance should become $15.10. Now if we add another command, cat add charge $15.20, the outcome of this command should be two outcomes. The first outcome is 15.2 will appear on the top of the transactions, and the balance will be updated, and the balance then becomes $30.30. Now we will create this method. So we will not have change balance, instead we will have add charge, and the balance, so x is the charge that is being added. So there are two steps. Step one is adding x to the top of the head of the transactions. So that means pushing the element to the stack, and the syntax for the push is aht is push ahtx, and then balance is increased by the value x. Our program still contains a bug. The bug is that once the object cat is created, the balance is not zero. The balance may be some garbage that was already in the memory, because all computer promised us is sufficient memory for one credit card account and the ability to call that cat. We cannot expect computer to put some number. We would like 0 to be the balance, and we would like null pointer to be the content of the AHT. If it's not null pointer, then everything is broken. However, we do not have a method that sets the balance, and we do not have a method that will set null pointer in the AHT. But C++ allows us to create constructor. Constructor is the method that is always called when the object is created. So when we give the command, dear computer, please give me sufficient memory for one credit card account and let me call it cat, we can also ask, once you do that, execute one default piece of code that will put 0 in the attribute balance and that will put null pointer in the address of the head of transactions. So the constructor is always called the same way as the class, and it has this constructor, this first version, will have no attributes. Constructor does not have return value, not even void. Credit card account is the name of the class. Credit card account is the name of the method. That is our constructor. And it starts by setting 0 to the balance, and AHT is a null pointer. Now our code will work, and we will now compile and execute this code. So we are now very happy. The total charge is $30.30. However, I have some bad news. Once the code is executed, if this was a piece of some longer program, this would create a memory leak, because now we have allocated memory on a stack, we stopped using our cat, and that memory stays allocated. So potentially we could use a lot of memory this way, and the programs may crash or the computer may end in a serious trouble. So what we will do here is we will create a destructor. Destructor is executed once we exit the block of the code, and destructor starts with this little sign that looks like snake and has the same name as the name of the class. It also doesn't have return value, and it's implemented in the following way. So we want to delete the stack, and I think we already have a method, delete stack. And we will set AH to null pointer. After deleting the stack. I will also print, once the constructor is executed, I will print a message. And once destructor is executed, we will also print a message. We'll print, "Thank you for letting me be your destructor." So I will also put this in a block of a code, so you can see when constructor and destructors are executed. The beginning of the main just before termination of the program. Oh, sorry, I have made a typo here. When I called the destructor, it should have been AHT. So, in the beginning of the program, before we entered the block of the code, we printed the message, the beginning of the main. Then, once we create cat, the constructor is executed and constructor is allowed. The constructor prints, constructor is executed. Then we print the balance. Balance is $30.30. And just as we are about to exit this block of code in which credit card account cat is allocated, when we exit the block of the code, cat is destroyed. So the destructor is also allowed and prints, "Thank you for letting me be your destructor." And then we have the last message just before exiting the code that gets printed. So we are running out of time. Bye. Thank you. See you in the next video.